Hydrogen gas, H2, is a colorless, odorless, and highly flammable gas that is the lightest and most abundant element in the universe. It is a simple diatomic molecule composed of two hydrogen atoms bonded together. Hydrogen gas can be produced by several methods, including electrolysis of water, steam reforming of natural gas or other hydrocarbons, and biomass gasification. It is used in a variety of applications, including as a fuel for vehicles, in the production of ammonia for fertilizer, and in the production of various chemicals and materials such as methanol, plastics, and electronics. Hydrogen gas has a high energy content and produces no carbon dioxide when burned, making it an attractive potential replacement for fossil fuels in transportation and other applications. However, it can also be dangerous if not handled properly, as it is highly flammable and can form explosive mixtures with air. As a result, special precautions must be taken when handling and storing hydrogen gas. Hydrogen gas is an important fuel for fuel cells. A fuel cell is an electrochemical device that converts the chemical energy of a fuel, such as hydrogen, into electrical energy. In a hydrogen fuel cell, hydrogen gas is combined with oxygen from the air to produce water and electricity. The process of converting hydrogen gas into electricity in a fuel cell is done through an electrochemical reaction that takes place at the electrodes of the cell. Hydrogen gas is supplied to the anode, positive electrode, of the fuel cell, where it is split into protons and electrons. The protons pass through an electrolyte membrane to the cathode, negative electrode, of the cell, while the electrons are forced to travel through an external circuit, producing an electrical current. At the cathode, the protons and electrons combine with oxygen from the air to produce water and heat, which is released as waste. This process is highly efficient, producing only water and heat as waste products, and can be used in a variety of applications, including transportation, stationary power generation, and portable power devices. One of the main advantages of using hydrogen gas in fuel cells is that it produces no harmful emissions, making it a cleaner alternative to fossil fuels. However, the production, storage, and transportation of hydrogen gas can still have environmental impacts, and the technology for producing, distributing, and using hydrogen fuel cells is still developing. Electrolysis of water. Electrolysis of water is a process that uses an electric current to split water molecules into hydrogen gas and oxygen gas. It is a chemical reaction that occurs when an electric current is passed through a solution of water and an electrolyte, such as sodium or potassium hydroxide. During the process of electrolysis of water, two electrodes are placed in the solution, and a direct current, DC, voltage is applied to the electrodes. The electrodes can be made of different materials but are typically made of inert metals such as platinum or graphite. When the current flows through the solution, it causes the water molecules to break apart into their constituent atoms, hydrogen and oxygen. At the negative electrode, or cathode, hydrogen ions, H+, are attracted to the electrode and are reduced to hydrogen gas, H2, by gaining electrons. At the positive electrode, or anode, oxygen ions, O, are attracted to the electrode and are oxidized to produce oxygen gas, O2, by releasing electrons. The overall reaction for the electrolysis of water is 2H2O plus electrical energy right pointing arrow 2H2 plus O2. The hydrogen and oxygen gases can be collected separately and used for various applications, such as fuel for fuel cells or for combustion engines. Electrolysis of water is a clean and renewable method for producing hydrogen gas, which can be used as a clean fuel source. However, the process requires a significant amount of energy to be inputted, and the cost of producing hydrogen through electrolysis can be high.